Hey, this is Hans from Request for Music, and on my screen you will see an image, a photograph that I just made of my original hardware version of the Formant synthesizer with all the modules that I had in place in that version and still have in place. Photograph is a bit bad, but I hope you can see all of the elements. You see a COM, which was sort of a final mastering kind of module where you had filtering, bass, treble, mids, and volume. You had your dual VCAs, the LFOs, ADSRs, noise, RFMs, 2040B VCFs, normal VCFs, and 4 VCOs. I built it from the center outwards because I wanted it to behave in a sort of a stereo fashion. So I had two VCOs coming into the VCF and the VCF 2040B and the RFM that side and the other way around. And you see the ADSRs as well from the center to the outside of the synth. Um, I actually just released Formant, the F SYN Origins bundle that sort of only uses these modules. Obviously, there was a keyboard with the synthesizer, and that had an interface. And on that interface was the glide and or the portamento, as it was called. That's not visible on this, but if I drag this out, you'll see the layout as I have it within my Voltage Modular at the moment. You see that I pushed my, if I compare this, I had some controls and other stuff in the center here. That some stuff that I created together with a friend of mine, like a ring modulator and a frequency counter that I needed to be able to to have it in tune, because otherwise it would drift very much, being a hardware oscillator, and it had sort of transistors that had a sort of a heating element inside to keep it as solid as possible, or as temperature wise and frequency wise, but still it would drift over time. Obviously, with software, you don't have that standard. Better still, if you want that, you have to put that into your software. Then there was this staircase generator, which was possible of creating a stepped or quantized version of, for instance, an LFO or something like that. But if I look at my Origins module or my Origins bundle, I only have the same COM, the VCA. It's not called a dual VCA anymore. There's some stuff otherwise than that in there. The noise module looks a bit different. I dragged the Voltage Modular standard block into the middle. You can actually do that by just dragging it on the side, as you can see. So I can drag it in between, or I can drag it on to the top. But that way I can have my gates going to the top, because that's what the ADSRs are using and VCAs will be using, and such modules. And the pitches and stuff like that will go down to the VCOs, and then they will interconnect. The original version was a semi-modular. That meant that there were no connections on the outside for some modules, because they were hardwired. The VCOs and stuff like that were hardwired to the VCFs, and the VCFs were hardwired to the VCAs and stuff like that. Also, the ADSRs, they were getting the gate from the keyboard, so you wouldn't need an gate input. For Voltage Modular, that behavior where you interconnect on the sort of the back end of the module is not possible. So I needed to create a gate input on the ADSR. I needed to create an external input, and actually that's what the switch also is for, that it really needs it, because otherwise if I switch this off, it will only have its own adjusted frequency, as you can have here. So that means that if I wanted to connect something, I'd have to do that all by myself. So just going over some standard stuff. If I use my pitch, the pitch would go, for instance, into my first VCO here in the external, and I need to switch that on because otherwise it won't respond to that pitch, and I will let you listen to that. But also I needed to have an input now on my VCFs. Normally that would be interconnected. Now I always have to put it from the output into the input of a VCF. And the VCF itself will have to go into the output of that will have to go into the input of a VCA. I will turn my wires on actually. So that is going into the VCA, and the VCA output would then go into my delays, my mixer, and all that kind of stuff. So if I do something like this, it will work. And so if I have a keyboard connected, if I have everything set up in sound, etc., then it will do that. So I don't have the envelope of the ADSR connected yet, so I need a gate. I need the gate to take to an ADSR, and I need the output to take to the envelope of my VCF. So that should be the first. On the VCA, I have this little button where this is the input for my gate actually. So if I switch this off, I will have sound because I now only, let's see if I have enough sound actually. Yeah, there's enough sound in there. So if I have this connected, the only wave that I have connected is my, or switched on, is my my sine wave on this VCO, the one that is connected. So this VCO goes into VCF, VCF goes into the VCA, and VCA by itself is not controlled now by the ADSR yet. I would have to do that via here. But that means that if I dial my VCF up, the cutoff frequency, that I'll get sound all the time. Yeah, so that's why you have, and that's also what you do when you want specific behavior. So if I take another sound or another sound source like a sawtooth, so I switch my sawtooth on, and I'll take it back just slightly, just so you're not getting completely mad of this. But it means that if I now use my envelope, which I do, and let's dial this back to have some sort of a, you will now hear that I actually change the sound by using the envelope here, and I can use my Q factor, something like that. But obviously I have my filter open because I want that sound, otherwise I would have this, and then the full sound sounds is different. So if I want something like this, I could actually take another ADSR and control the VCA. So if I switch this on, it will be silent because its behavior is now changed by the envelope. But obviously this ADSR now needs a gate as well. So this one is fully open, so the sustain is open. So it remains open as long as I, oops, let's not do it like that. Let's take this. So it will stay open as long as I press a key, right? So I'll have it pressed, and now I'll let it go. If I want it different, I could, for instance, use the decay, because the decay is the phase that goes in as soon as I press a key. So I have a short decay, I don't have any sustain. So now it's sort of, I'm pressing, I'm holding the key, but it's leaving, the sound is leaving, it's skipping sound. So I could use a release, something like this, where the release makes sure that it has a phase after you release the key, right? So so that's what the release is for. And then for the rest, yeah, you can do whatever. So now I only use one VCO, but it would be pretty simple to just take that same pitch that I had here and use that in a second VCO. So I've got this, that one is switched onto a square. I take this out and put it into my input as well. So now that one is sounding as well, and of course that is very yeah, very narrow stereo field because I'm only using one VCA, and that was in my original hardware as well. So that's why I normally did it in such a way that I would then take my fourth VCO and connect that to the other side, and go to the other VCA, and the VCA would go into my second channel. So if I would try to mimic that, I would take my VCO pitch and not put it in this one, but put it in my fourth VCO here. And let's use the same sort of setup. See the same kind of volume as I had here. I'll take the output, and I will not be putting the output into this VCF, but I'll take this VCO out into that VCF. That will need an envelope. So I might take another one, and let's sort of mirror the same kind of way. So I'm going to use this ADSR as the envelope setting for this VCF. So obviously this one needs a gate. This one is going out to my VCA input. I could check by first doing it like that and switching off the envelope handling and take my output to my other. So now I got two sounds. So something like that. But then obviously I could do the same kind of thing. I could take my VCF, and actually I have connected it to my normal VCF. Actually, on this Origins version that I created, I do have VCF 2040B, but it's built into one. I didn't want to create a separate filter for 2040B, so I've got one with a switch 12 dB or 24 dB. So actually it is the same sort of setup as in the original hardware version, but I use the same module for it. It is being a 24 dB filter when this is switched on, and if it's switched on, it's a 12 dB version with high pass, band pass, low pass, and everything in there. So I've connected it to the 12 dB as this was. 12 dB is going to the input there. I'm going to take the output of the other gate with of the other envelope, which then obviously needs I don't don't think I have it mirrored. I have it a bit backwards, but anyway, I hope that you understand what it does. The gate is still going into this, and the ADSR is driving the envelope of this, but then I need to switch this on. So now I've got this, and then obviously if I change my ADSRs for either, so if I change this ADSR, which is driving my filter, I would have something like this where I don't have or have lower sustain. So you hear that it dies out sort of. And now let's do something similar to my ADSR, which is driving the VCA. So I'm taking a longer decay and I'm taking a little longer release. So something like that. And obviously it's now pretty clean, pretty clear. It's just that output, and that's all there is. In this setup I did put the original delay from Cherry Audio. I could have used my own F SYN modules, but if someone bought the Origins bundle, which only contains this, the F universe delays and reverbs and such are not within that same bundle, so you would have to take your own. Of course, I could now take the input of that one into the first delay and the second one in the second delay, and take its output into my my main connection from Cherry Audio, from Voltage Modular. So now I've got some kind of delay anyway. I don't hear too much from the first one. Let's see why that is. Should be there. There it is. And I have some difference in time between those two, and I could take the feedback up. So make it full stereo sort of, but it's it's pretty nice having it just floating just a bit off. Something like this, and but for the rest I don't need to see those, so that's why I put it on the side and just use this as a main thing. For the rest, all of the same kind of things still apply from a hardware synthesizer. I'm going to switch off my cables so you won't see them, and it might have been better to change colors, like for instance all of the gates that are taking out. If I right click on this, I could actually take red cables for that. I also use something like that on my original hardware version, where I gave certain colors to certain sort of cables. So all of my pitches could be, for instance, something like a grayish, dark gray cable or something like that. So these are all the those connections and the audio connections coming out from the output of the VCO and of the VCF. Well, let's leave that in the light gray. So all the light gray cables are audio cables, because that's the output of my VCO, and which is going on. Actually, this I could think of those as being control signal or something. So because the gate itself is red, but this is a control signal. So let's put those in this light blue. That was not light blue. Or maybe orange is not that bad, because it's sort of related to that signal. So the only thing is that I don't really know which color it was right now. So I'll take this one on top, and I'll take that one as well, and this one. If multiple cables are connected, you can actually use them at the same time, as I did with these cables coming from here, from the gate, but the pitch and the pitch as well. But if they're separate cables, only one's connected, you'd have to do it this way. So now I can easily see that even when I don't see the cable, that this is a connection for control voltage or something. So I could do that. LFOs have green knobs, as I had in my original, so I could use that in green as well. So for instance, frequency modulation, like on my VCF, this is one of the VCF that is switched on. Maybe I can switch those off here so I recognize better that these are my VCOs that I connect. I could easily even switch off the oscillator, so I see that there's no other signal coming out of those. So if I take this, I could, for instance, take one of the LFOs, and each of the LFOs in the hardware original had the modulation or the time knob, but it had three outputs: one for square, one for triangle, and one for sawtooth. And the both two top ones have the same kind of connections, while the other one on the bottom has the ramp as well as the sawtooth. So that's the only difference. And on one sort of a layer or lane, or how you would call it, there's three connections which run at the same speed but still have different outputs. And so you have three of those LFOs in one LFO module, and you have that on both sides. So you have ample LFO possibilities. So I could take this out, and let's drive the VCO in here, because this is pitch modulation, frequency modulation. So let's switch this off and take the VCF on. This switches off my envelope, so it does not respond to the VC envelope, and my VCA signal is just going into the output straight away. But if then I dial up my VCF, you can hear that sound. So now I will hear what my frequency modulation is doing. So if I wanted to have some sort of a vibrato, I'll dial that up, and I'll dial this up, not too high. I could do something like this, but that would be too much, of course. And if I wanted something different, that would already be a problem in this setup, because actually, for instance, if I wanted to have something like mod wheel connectivity, and use of that LFO, I would have a problem because there's no utility in there to just have that VCA, to have the amplification of that signal, because then I would have to amplify an LFO by the modulation signal to do that. And that's why for my F SYN bundle I created a lot of modules, separate modules, that would do something like that. So I'll leave that for what it is for the moment. I could do that in a new video afterwards, but let's first of all, let's dial this in again. Let's switch the VCA on again. So something like that. So yeah, that I hope that gives you some idea. And as said, it would be easy to just take the pitch from, for instance, this VCO into my pitch output as well, and I would just have to put this into the same VCF, so that would be connected as well. So let's take this sound and at some points I need to I have to switch it on, of course. And dialing the fine tuning and dialing it off a bit. This thickens the sound, right? So I could do the same thing on the other side. So take the external into the pitch here, and that one is not black yet, or the dark is gray yet. Take this as well, put this into my input of the VCF, and switch on. And maybe I want to dial this back, so I'll double click my course and I'll put that on -1, something like that. And maybe if I want this sound to be on the other side as well, I could easily take a next cable and put that on the other side. So something like that. Well, that was the first thing of this Origins synthesizer, and actually also a sort of an explanation of what the original hardware version was like and how you intended to work with that. So I hope you like this one, and I'll see you back in another video. Cheers. Bye bye.